Hello and welcome to another exciting Breakfast with Unity. I'm your host, Max Moreau, and what we're doing today is we're going to add some physics impact sounds for our little dice thing. We hadn't done this before at all on the show, I don't think, and it's actually something kind of important if you're making any physics-based games to have some, Havoc sounds, as what we call them jokingly, but it doesn't have to be exclusive to Havoc. Obviously, we're using physics here, and there's going to be some physics sounds involved. But I say Havoc sounds jokingly because you remember in games like Half-Life 2 is a good example just because it was so early for physics interactions in games, and not as early as like Jurassic Park Trespasser, but that's another whole story entirely. But just remember when you'd get like an object stuck between two things, you hear. We're probably going to be adding that here, but that's fine. That's what we want. We want to add a little bit of thump sound to when we hit things. So I've added some audio to the library here. This is from Open Game Art as well. So we've got these two pumpkin break sounds, and I've got the information in this text file, but I'm just going to show it on the screen here. It's from Tiny Worlds here, and he just has a couple pumpkin breaking sounds, which I think sound pretty good for a basis, not that one so much, for hitting things. So we'll see what we can do to work with it and make it sound really good. So we're going to create a new folder. New folder. Call this 57. Physics sounds is what we're going to call it. And we're going to base this one on our Dice Roller 3D one. So I'm going to duplicate this scene and put it in here. Whoops, put it in here. And we're going to call this with sound. And we're going to open it up. So right now we've got, it's a lie. It says Dice Roller with sound, but it just has the die, and it does not have a sound. So if we roll it, it just does that. And we don't hear anything. So we're going to want to play sounds on this thing. So I'm going to go ahead and on the die, we're going to put Pumpkin Breako 1 on here. And if we hit play, we should just hear it play once. We heard it. Cool. Just wanted to make sure that it was in there. So we're going to turn off Plan Awake so it doesn't play when we start. And we're going to add a script that does some stuff to make the sound play. So I'm going to call this play sound on collision. Alright, that's what we're going to call it. And I'm going to go ahead and quit this thing. So let's start by just making it play the sound. So all we're going to do is we're going to have a public float impact threshold. And I don't know what will be a good default value for this, so I'm going to set it to 0.1f. I'm going to call it, impact threshold. We'll see what this actually looks like when we start coding it. We might rename it. So what we're going to be doing is void on collision enter. And this time we're going to be using the collision information here. So we're going to call it collision. So this has information about the collision we just had. And one of the important things it has, collision dot relative velocity. So this is the velocity differential between the objects that you've just impacted. So what this means is if an object is traveling at 50 units per second to the left, and an object is traveling at 50 units per second to the right, and they hit each other, this would represent a vector 3 that with a force, with a relative velocity of 100, and I actually couldn't tell you which direction it would be in, but yeah, because the velocities were so different, they'd have that differential. So we're just going to use relative velocity, and if collision relative velocity is greater than impact threshold, then we will do audio dot play. Save. Alright, so play. And I already did something wrong. Oh yeah, and that's because this isn't a float. We need to have the magnitude. So I'm going to do dot magnitude. We could pre-square the impact threshold and save us a square root operation in the magnitude thing. I'm not going to worry about that right now. So we hit play and we kick the thing, and we don't hear anything because we didn't put the script on the die. Correct? That's what I missed? Yeah. The usual. So place sound on collision, we place it on the die, and hopefully we'll hear something. There we go. That was easy. Alright, so now let's make it a little bit more robust though, because right now it's just playing the sound the same way every time. Let's try and give it some variation based on the speed. Now this gets a little bit trickier. So, let's do min impact velocity is what we're going to call it now. So we're going to do min impact velocity. And so we're going to do public float max impact velocity equals, let's just set it to 1.0 f right now. And then let's create a couple extra variables. Public float min, what do they call it actually on here? They call it pitch. It should be called speed, but they call it pitch. Min pitch equals 0.5 f. Public float max pitch equals 1.5 f. Alright, so we're gonna have this actually adjust the pitch and the volume based on how lightly we tap it or how heavy we tap it. So what we're gonna do is audio dot volume. We're just going to reduce it linearly, which is not exactly accurate, but we're going to try that first. We're just going to reduce it linearly based on the impact velocity settings. So what we're going to do is audio.volume equals math f dot lerp. We're going to do a linear interpolation between, we're going to go between 0.0 f and 1.0 f, and then the t will be our min impact velocity, max impact velocity stuff. So it would be what would it be? Be max impact velocity minus min impact velocity. So that's the min impact velocity. So that's the upper range, and then that would be, it would be a percentage of this, which I'm going to calculate separately. We're just going to store this in a variable now. Float impact velocity equals, so we do impact velocity divided by max impact velocity minus min impact velocity. I think this will get us what we want. Oh, I think we have to also add I'm probably doing this a little bit wrong. Let's just do the, let's see what happens. Let's see what I just did there. So this should change the volume, but let's also change the pitch real quick. And I evidently missed one of these. So let's do audio.pitch equals, so hold on. So if impact velocity was 0, this would end up being 0. If it was 1.1, it should end up being 0 as well, which it does not. It ends up being a little bit more. So we have to subtract min impact velocity from this side. Hold on. And this we actually don't have to change anything, right? Yeah, that's how we actually want it. But we need to make sure that this calculation happens first, which it won't because order of operations. So save that. So pitch is going to be same deal, except for instead of lerping between 0 and 1, we're going to lerp between min pitch, and max pitch. Save. I think this is going to work. So, unexpected symbol if. Forgot to put one of these, and we forgot to actually do the point of this, so we don't have to calculate it twice. Save, and we're using that impact velocity here. Yep, cool. So if we hit play, this should already sound better, but let's see how it goes. Alright, so let's change our values a little bit. Let's see. Let's put the min impact velocity at 0.5 and see how that cuts things off real quick. It's actually changing. Okay, volume 1, pitch 1.5. Okay, so yeah, we're hitting this way harder than we want to be hitting it. So let's make the max impact velocity 10 and see how this goes. There we go. There we go. Starting to sound more like a die. I'm liking that. I'm liking that. So let's do 0.5 and 10 as the maximum. And let's make it so the pitch can go a little bit higher. Let's make it so it can go way high. And let's see how that sounds. I like it better with a little bit lower. But yeah, you can get some different sounds out of this. And this is just one sound file, and we can get a huge range out of it just by adjusting things based on the pitch. I think that sounds pretty good. I'm going to save this. I'm going to do one more thing. We're going to do an optimization because we have a little bit of extra time. So I mentioned that we can avoid this square root check by making it a square magnitude. But then we have to check versus the... when we have the impact velocity, then we need to actually check these values based on their squares. And so one way we can do that is to kind of create a little cached thingy. So I'm going to create I'm just going to show how to do this because it's kind of fun. This is not required to make this work, obviously, and this will not save you much in this case. But getting in this habit, if you can avoid square roots, especially if you're using them a lot, like this one doesn't matter too much because it's only happening on the collision check. So it's only happening. It's not happening once every frame or something. But if you have something that you need to check this once every frame, this type of optimization will help you. So we're going to get to practice now because we've got the time. So we're going to do public float. What is it called? So we want square min impact velocity. And this is going to be an accessor, and it's going to just have a get. So this is like a variable that you can grab that just has extra things that it does in the meantime. And we're going to also need a little storage thing. We're going to do a private float, and I'm just going to call it this, but with an underscore. And what we're going to do is we're going to set this equal to 0.0f. So we need to know if this thing has changed. So we're going to need one more variable here. Private float, square min impact velocity, and last min impact velocity. So if last equals min impact velocity, return last min impact velocity. Sorry, return square min impact velocity. And else we're going to calculate square min impact velocity equals, so in this one we set last min impact velocity equals min impact velocity. Square min impact velocity equals min impact velocity times min impact velocity. Return square min impact velocity. Is there a way I can make this slightly more clear and not repeat myself quite so much? So we'll just do it this way. If we do that, then we don't even need an else statement, we just return. So if this does not equal that, then do that. So what this is doing is when we get our square min impact velocity, it checks to see if our last min impact velocity equals the min impact velocity. If it does not, it recalculates and squares it. Otherwise, it uses the cached value. And now, all of a sudden, we can just use square impact velocity. And I really shouldn't have changed that, but I'm going to just do that so that you know that what we're doing. And then instead of using min impact velocity, we use square min impact velocity. All right, and so there we go. And what else are we doing? So we need to do that for max impact velocity as well, which will be easier because we've already got these variables set up. We just do this again, boop, and this time we're going to call it max square max impact velocity and max like max is great. Max and max and max, two more maxes, max and max. Save. And then we can do the same thing here. Square save. Impact velocity is not, oh yeah, if SQR save. See if it still works and sounds the same. Looking good. So yeah, you'll see that, as I said, in this case, probably wouldn't have saved us that much to actually make this optimization. And this is a little bit complex and convoluted compared to what we usually do. Why are we storing all of this stuff? Well, we have to store we have to find out if the player has changed the value, right? And we can't just say if the value doesn't equal the square, because then we're doing the square operation anyway. So we need to have something that we can use as a cache check. So this is a cache check here. So if this value, which just gets set automatically here, doesn't equal this value, that means that we've changed the value since last time we've called square max impact velocity. And so then it will do the recalculation. Otherwise, it will just return the cached value. And so it'll just skip this if statement and then return the cache value, or it'll calculate it if it needs it. And so this makes it so this will effectively be a cached value every time after the first. So you only have to do the squaring once. And the squaring is actually, I think, actually an easier calculation than square root, believe it or not. So even if it didn't cache, it's still an advantage to pre-square the values, but this gives you a cache advantage as well. So hopefully that makes some sense. Went over a little on time, but I figured that maybe that extra information might help someone. Anyway, thank you very much for watching. If you have any questions, please email me pushypixels@pushypixels.com. You can also tweet me at Drakfire. That's DRAKFYRE. And please donate. Patreon.com/CookingWithUnity. Really appreciate your support. Yeah, have a good one, and I'll catch you tonight with something. Might do more 2D Thursday, we might not. We'll see. Anyway, see ya!